base, salt. Acid taste is going to be sour and base taste is going to be bitter and soapy. And remember, when you have an acid which produces the H plus ions and base which can produce the OH minus ion. In the taste, it is having sour taste, base is more bitter and soapy taste. When you compare them to test whether it is an acid or base, we have the test litmus paper, phenolphthalein, methyl orange. Litmus paper can have turned to the acid, blue litmus paper to the red litmus paper, color to the blue color to red color, base red color to blue color. Phenolphthalein is an indicator which is also used to test the acid and base. Phenolphthalein will be the colorless when you test with acid. Phenolphthalein will be pink color when you test with the base. Methyl orange, in the acid it turns to the pink color, in the base it turns to the yellow color. So these are the tests for whether it is an acid or base, and it is not used to test whether pH value. Only whether it is an acid or base can be decided by using this color. And what is the difference between the litmus paper and as a phenolphthalein and methyl orange? Usually, if there is any substance that can be checked with the litmus paper by seeing its color, but usually we don't find exact color difference in the litmus paper. Usually we see it as a pink color, but say it as a red. A litmus paper will be the form of a pink color, but usually we call it as red color. So the color identification is not clear when you test with a litmus paper. Usually it seems to be a pink color, but we call it as a red color. So that is only the reason to test exactly the color. We use a phenolphthalein solution or methyl iron solution. And you can call all this called as a universal indicators. What do you mean by the universal indicator? A universal indicator which is used to test acid or base or neutral solution where it is a combination of several indicators. It may be a litmus paper, it may be phenolphthalein, it may be methyl orange. Just we can call it as universal indicator is the one which is used to test with acid or base. It may be in the form of a substance, it may be in the form of a liquid. So this is test whether it is acid or base. And when you come to the point of the pH value, pH in the sense power of hydrogen, usually it is the form of a scale, turns from 0 to 14, and in between there is a 7. When the value decreases from 7 to 0, strength of acid increases. When the value increases from 7 to 14, strength of base is going to be increased. pH stands for power of the hydrogen, which is used to test the strength of acid, strength of the base. Before we have read universal indicator which is only used to test whether it is acid or base. No strength can be identified by using the universal indicator, say it as litmus paper, phenolphthalein or methyl. Just by seeing the color, we can confirm whether it is acid or base, but we cannot identify its strength. If we wanted to identify the strength of acid, strength of a base, we will be using the pH scale, say it as a pH value. pH stands for power of hydrogen. pH value will be 0 to 14 and 7 number indicates the neutral solution and 7 to 0 acid, 7 to 14 base. If the value decreases from 7 to 0, strength of acid increases. If the value increases from 7 to 14, strength of base is going to be increased. Say it as, for example, 6, 5, 4. Say it as a weak. And 3, 2, 1, 0. Say it as a strong. And when it is the other thing, 8, 9, 10. It is going to be weak. 11, 12, 13, 14. Say it as strong. So it is confirmed that exactly 7 value is going to be neutral. And generally we call the water as is universal. Water is a neutral solution, but remember its value always lesser than 7. That exactly around 6.8 to 6.9 water value, because it is slightly acidic nature. Water is usually called as a neutral solution, but its pH value will be 6.8 to 6.9. It is slightly acidic nature. So this is the scale which is used to find out whether it is a strong acid, whether it is a weak acid, or whether it is a strong base, or whether it is a weak base. Just by seeing this, we can identify the acid. And remember, when two are strong, reaction never takes place. It may be a strong acid, strong base. It may be a weak acid, weak base. Either two are strong or two are weak. Reaction never takes place. When two substances are taking reaction, one should be strong, one should be weak. Just like strong acid, weak base, weak acid, strong base. No two solutions must be strong to take the reaction. When you go to the properties of them, first property, acid, base with metal. And this example you can write in your own. Not exactly it is given in the textbook. See, as your general formula, acid plus metal is gives rise to salt plus hydrogen gas. Or same as base plus metal gives rise to salt plus hydrogen gas. Now you can take an example. Hydrochloric acid is an acid. Take the zinc as a metal. It produces ZnCl2 plus H2. So it has a balanced equation 2. And let's take the other one, NaOH plus Zn. It forms as a Na2 ZnO2 plus H2. And when you go write as a 2NaOH. This is called sodium zincate, zinc chloride, hydrogen, hydrochloric acid, sodium hydroxide. Writing the chemical equation should be known its name also. Hydrochloric acid, zinc gives rise to zinc chloride and hydrogen gas, whereas the base, sodium hydroxide reacting with the zinc produces the Na2ZnO2. Say it as a sodium zincate. And hydrogen gas. This is the first property when acid and base reacting with the metal. And same second property when acid reacting with the metallic oxide. Acid with metallic oxide. Acid plus MO for metal oxide produces the salt and water. Say it as a H2. You can write as a water also, not a problem. Now take your example. Acid, I am taking the HCl. Metallic oxide, ZnO, is gives rise to ZnCl2 plus H2. Usually, if it is a metal, we have produced a hydrogen gas. If it is a metallic oxide, just oxygen is extra. Is a comparison. Just take it. HCl, Zn is gives rise to ZnCl2 plus H2. This is the comparison between the metallic oxide and the metal. When acid is reacting with the metal, produces the salt and hydrogen. When acid is reacting with the metallic oxide, just oxygen is extra. So that H2O is added. This is the clearest difference between the metallic oxide and the metal. If there is a metal, you may produce a hydrogen. If there is a metallic oxide, hydrogen oxide, say it as a water. And next property, acid with carbonates. Carbonate and bicarbonate. See, acid plus carbonate gives rise to salt plus carbon dioxide plus H2. These are the common products for all. And acid plus hydrogen carbonate, also it is called bicarbonate, gives rise to salt plus carbon dioxide plus H2O. Both are same. What is the difference between, here a carbonate say it as a CO3, hydrogen carbonate say it as a HCO3. This hydrogen carbonate is also called as a bicarbonate. In the carbonate also salt, carbon dioxide, water produced. In the bicarbonate also salt, carbon dioxide, water produced. What exactly difference? Quantity of the salt will be changed. When acid is reacting with the carbonate, quantity of salt is going to be more. When acid is reacting with the bicarbonate, quantity of salt is going to be less. Let's take an example. I am taking a HCl Na2CO3, hydrochloric acid, sodium carbonate produces the NaCl plus CO2 plus H2O, say it as a 2NaCl. And now same HCl I am taking as NaHCO3, hydrochloric acid, sodium bicarbonate or sodium hydrogen carbonate gives rise to NaCl, CO2 plus H2O. 2 moles of sodium chloride, 1 mole of sodium chloride. This is the clearest difference between when acid is reacting with the carbonates, when acid is reacting with the bicarbonate. And first property acid base is reacting with the metal. Second property, acid is reacting with the metallic oxide. Third property, acid is reacting with the carbonate, acid is reacting with the bicarbonate. Usually, we don't concentrate how the base are reacting with it. Usually, generally, base are reacting very less. So, our concentration totally on the acids. So, acid reacting with 3 properties are the acid with metal, acid with metallic oxide, acid with the bicarbonate, acid with the carbonate. Now, when acid is reacting with the base, what happens? What it is called? Neutralization. Acid plus base gives rise to salt and water. This is called neutralization solution. Neutralization process. When acid is reacting with the base, produces the salt and water. Generally, all the acids produces H plus ions mostly. All the base can be produced as a OH minus. That is only the reason when they combine together, what is going to be produced. Take an example, acid example HCl, base example NaOH, gives rise to NaCl plus H2O. Whenever we write a chemical equation, it is compulsory to write should be a balanced equation. So there are the two differences, skeleton equation and as well as a balanced equation. If number of moles left hand side is not equal to number of moles in right hand side, then it is called as the skeleton equation. When number of moles left side, number of moles right side are equal, then it is a balanced chemical equation. Whenever you write an example, should be balanced one. Chemical equation, chemical reaction. Chemical reaction where you are representing that how the chemicals are participating in the reaction. But when representing the chemical reaction in the form of their symbols, say it as a chemical equation where you are separating the reactants and as well as the products. For example, if I say acid is reacting with the base, produces the salt and water. This is reaction. When I say that acid reacting with the base produces the salt and the water. So this is the explanation of the reaction. But when I am writing to the symbol HCl plus NaOH gives rise to NaCl plus H2O. This is called as equation. An equation is separated with the arrow. Left side reactants, right side products. What do you mean by the reactants? What do you mean by the product? A reactant, chemical substance which are participating in the reaction or which are responsible for the reaction, say it as reactants. So these are all called reactants. And products which are the results of reaction, say it as product. So hydrochloric, just we can say it as a chemical equation is separated with the reactant and as well as the product by separated with the arrow mark. Here arrow mark indicates in which direction reaction is taking place, either left to right or right to left. So this is what exactly acids and base in the compound. And one more important concept is acids and bases can raise the ion only in aqueous solution. What do you mean by aqueous solution? See, for example, I am going to take a dry HCl and HCl. When you try to test with a litmus paper or a methyl orange or phenolphthalein, you cannot find any color change because this is not aqueous. Aqueous is nothing but combination of water. A chemical substance is combined with water, say it is aqueous solution. If an acid or the base, it is not an aqueous solution, say it is a dry, you cannot find any test. Right? Maybe a litmus paper, it may be a phenolphthalein paper, it may be a methyl orange test. So we should understand that compulsorily to test or to have the properties of acid or base, it must be an aqueous solution. That means it must be added with water. See, if you are testing a dry HCl with a litmus paper, no color change. You don't find anything. But take a litmus paper which is wet. So I can say it as dry HCl plus litmus paper, no change. Same as dry HCl plus wet litmus paper, color change. So completely we understand that if you wanted to test or if you wanted to check the properties of acid, properties of base to be exhibited when it is having a aqueous solution. If it is not aqueous, you cannot check whether it is a acid or base by using either litmus paper, phenolphthalein or methyl orange. So conclusion is all the acids and bases produces or exhibits their properties when they are in aqueous state. And remember, diluted, strong in between. What do you mean by strong? What do you mean by, say usually we call it as dilute acid, dilute base, strong base. Remember, when it is a strong base or acid, it do not produce the ions. When it is a dilute base or dilute acid, it can produce the ions. So that is only the reason when you wanted to test with electricity or when you wanted to check with the current, it should be the diluted one. Some impurity should be added. What do you mean by the diluted? The strength should be reduced. The strength should be reduced. Simple example you can tell you. When you are adding the 1 glass of milk added with 7 spoons of sugar, a glass of milk added with 3 spoons of sugar. Which will be the stronger? First one will be the stronger because quantity remains the same, 1 glass of milk. First case you have added the 7 teaspoons. Second case you have added the 3 spoons. So initially you have added the 7 teaspoons, added the concentrator. So sweetness is going to be more. But when you are at the 1 spoon or 2 spoon or 3 spoons, sweetness is going to be less. So if you wanted to change its sweetness, see for example 100 ml of milk you have taken and 8 spoons. So the sweetness is going to be more. If you wanted to reduce the sweetness, what do you do? Either adding the water or adding the milk. Is it clear everyone? 100 ml of milk added with the 8 spoons of sugar. What happens? Sweetness is going to be more. Now you wanted to change the sweetness. What will you do? Now it is a stronger one, means concentrated one. Now what will we do to reduce the sweetness? We will be adding the either water or milk so that this quantity will be increased. So that its quantity will be reduced. So we are not changing any sugar because of already it is added, you cannot do anything. So you can do only either changing either adding the water or milk, the sweetness is going to be reduced. So compulsorily remember, when it is a strong acid, strong base, it do not allow the current to pass through it. Why? Because it never raises ion. If you wanted to allow the current to be passed, it should be raises with ions. If ions are not raised, current never be passed. Strong acids, strong bases do not raise these ions easily. If it is a diluted one, it will produce ions, so the current will be passed maximum. That is the reason a strong acid can allow the current to pass through them, it's less. A diluted acid can allow the current to pass through them as more. There is a comparison between them. So these are the properties of acid and the bases. Usually the two parts are there. What are the preparations in the acids and bases and salt? What are the properties? So what we have learned about the so far the test of the litmus paper, phenolphthalein as well as the methyl orange, and how the acids are reacting with the metal, how the acids are reacting with metallic oxide, how the acids are reacting with the carbonate, how the acids are reacting with the metallic bicarbonate, and how the acids are reacting with the base. These are properties. And why should they have the aqueous solution? Because they do not produce their properties when it is not a aqueous solution. What do you mean by the aqueous solution? It should be added with water. And it should be, if it is a strong acid, strong base, do not raise this ion, so current cannot be passed easily. When it is a dilute acid or a dilute base, they can raise these ions more, so that current can be passed easily. Example, what are the color changes? And universal indicator is nothing but it is an indicator which is used to test whether it is substance which is used to test with acid or base. It may be anything. What indicator? Universal indicator. Universal indicator is a combination of the indicators such that different colors will be produced as per the strength of acid. For example, if you take 4, 5, 6. If the pH value of an acid is 6, it will produce some other color. If the pH value of acid is 4, color also will be changed. So according to the strength of acid or base, colors will be changed. That is the reason you say it as a universal indicator. It is used to test either substance or the liquid. So these are the things. First part of your acid, base and salt. And when they are asking the example, you need not to buy heart the thing. Simply they will ask how the acids are. For example, the question is asked, write the property when acid is reacting with the metal. You should write as the acid is reacting with the metal